Good morning, Laxman.
Good morning, all of you. I hope I am audible. Okay, as per your request, I want to give some demo kind of thing on Kubernetes. So it should be here. Why it came here? Something got messed up here. What is Docker? Can any one of you please tell what is Docker?
Docker is the containerization tool.
What it is?
Containerization tool, and also OS and its dependency.
Okay, containerization tool. Okay, that's fine. Docker is as you people said, Docker is a containerization tool. What is containerization? The process of creating or making containers is called as what? Containerization. What is Kubernetes? Kubernetes is container orchestration tool. Kubernetes, or most famously it is also called as K8s. Why it is called K8s? Because between K and S we will have 8 characters. 1, 2, 3, 4, 5, 6, 7, 8. So it will also be called as K8s. Kubernetes is container orchestration. Container orchestration tool or the platform. What is orchestration? What is orchestration? The arrangement or scoring of music for orchestral performance. The planning or coordination of the elements of the situation to produce a desired effect, especially what is it? First time I am hearing this stuff. Sir, okay. I don't want to spell that out. Surreptitiously. First time I have heard this word. Anyway, so what it is? The planning or coordination of the elements of the situation to produce a desired effect. I think this suits the our context. Okay. So orchestration means planning or coordination of the containers to produce the desired output. That is called as what? Orchestration. Orchestration simply means planning and coordination and management of containers is called as what? Orchestration. What kind of management, what kind of coordination, what kind of planning we do in the Kubernetes. For example, let's say we have a front-end application running inside a container. We have a front-end application running inside a container. It's a web server. This is a container. Container. The web server is running inside that. It's a front end for the request. So request will be coming to this application, this container, we can say. More specifically to this server. So today, let's say we have for some e-commerce website, let's say Flipkart, only within India. during daytime, what will happen? And during especially festive seasons, the number of requests, the number of people that will be hitting the flipkart.com will be rising during certain time. Okay. So in that case, this particular container may not withstand the traffic. What we have to do? We have to create multiple replicas of the server. We have to create multiple replicas of the same application so that the request will be distributed. The request will be distributed to multiple containers so that there won't be any downtime. Even if lakhs of people, thousands of people are.
Voice is low. Hello?
My voice is low.
Yeah,
Yes,
yeah.
yes, sir.
Okay, let me disconnect. Audio to Bluetooth. Is it fine now?
Yes, it's good.
So a lot of requests will be coming. This container is not able to withstand those many requests. So we should have a mechanism. We should have a mechanism to create multiple replicas of this web server. That means we should have a mechanism so to scale up the container, scaling up. And whenever the traffic has got decreased, and automatically scaling down should happen. And this should be automated. This should be automated. So that is what one of the function of the orchestration, one of the aspect of the orchestration. Management of the containers such that containers will be scaled up when the traffic is being increased and the containers are scaled down when the traffic got decreased. That kind of activity is a part of orchestration. This is one thing. And it not just scaling up and scaling down. When they are scaling up, they should not be scaled up. They should not be independently working each other. There should be a mechanism to load balance. There should be a mechanism for load balancing the request across multiple replicas. Okay, so that is one thing. Another aspect is what? Load balancing. How the load balancing work? There should be a proper networking solution. Okay, so with that networking only load balance can be happening. So this is, and one more thing is, these 4 replicas are now up now. What if one of the or 2 of the replicas are down? There should be a mechanism for self-healing. We desire to have 4 replicas, but due to failure of the 2 replicas, only 2 replicas are running. But what if the traffic is being increased? Definitely, there should be a mechanism for this container to be healed. Okay, that is called as what? Self-healing. Self-healing of the containers. That is how these kind of activities is called as management or the orchestration. To perform this orchestration activities, we have a beautiful tool called as the Kubernetes. Okay, so using this Kubernetes, we will manage the containers. Which containers? In our case, Docker containers. This Kubernetes will also manage containers or orchestrate containers that are created by the other tools like Podman, Rocket. But the most famous containerization engine is Docker. Who invented Docker? Salman Hikes. Then this Kubernetes is used to perform that orchestration. And it's not just like scaling up and scaling down the container. These containers should be distributed
are deployed in a distributed environment. That means if we use Docker, we can done them only in a single Docker machine. But in Kubernetes, now a distributed environment, we can have multiple worker nodes. Okay, so in this,
Sir, I have one question in previous diagram. No problem, even if my diagram is not there. Like common question, like if we are using multiple containers, suppose take an example for an application, okay, for 4 applications. And at the end, we are running that containers, all the containers on the any of the cloud service provider or any of the VM, right?
yes.
So the resources for that VM will be allocated once. Suppose take an example, 2 GB of RAM and 100 GB of the hard disk or 500 GB hard disk. So while these 4 applications are running, that RAM and resources will get utilized from that VM only. So even if we are using the Kubernetes to manage it, it's okay. But at the end, the resources are getting utilized from that VM only, and that VM will get charged as per that resources, like whatever resources we are using. So what is the benefit?
Okay, you are telling something like even if it's a Kubernetes or whatever, we are using the VM's resources only and VM's got charged, right? But who will deploy these containers? Who will perform this orchestration? Definitely tools will be there. Can you perform this? Can you create the containers with your own VM without having Docker or any containerization platform? And even if you have that, you don't have that. Even if you have that, how can you perform this orchestration?
Or orchestration, managing load balancing, and what we say, scaling up and scaling down, it's fine. Like I understood that. That for that it's Kubernetes is best, I can understand. But regarding the volume and resources utilization, I'm asking in terms of that.
Okay, yes, those resources will be consumed by the VM from VM only, because these containers will be running on the VMs only.
Okay.
Am I clear?
Yes. But we are getting charged for that only, now, like whatever services we are using. Like
Yes,
even if we are scaling up or scaling down, suppose take an example, we need to scale up to 8 containers. Okay. At the end, to scale up to that 8 containers, suppose take an example, each container will take 1 GB of RAM.
yes.
So at the end, we need at least 10 GB or 8 GB of RAM in the VM also. To,
Yes, we should have. Not in the
yeah,
VM also. We should have that VM only.
yeah, and then my point is like, for that at the end we are paying for that 8 GB of RAM for cloud service provider in any of which.
Yes, we have
So
to provide. We have to pay for that. Definitely. If you don't want to pay for that, you please design your own VM.
no, like I need to understand. I'm trying to understand in that way. Like at the end, the resources are getting utilized and we are using that. So like how it is helping in terms of only load balancing and scaling up and scaling down
Yes, yes.
automatically. Okay.
Yes. So now one thing is, now we will run that containers in a distributed environment, as you said, in multiple host machines. Here, what will happen if you want to have those 4 replicas will be running one here, 3 here. And because this node is somewhat big in the sense, it is big in terms of resources like CPU and memory, and one more container will be created here. And there is always a networking solution between all these containers, okay, and across these machines as well. And this will be acting as the manager or the control plane in the Kubernetes. So even if one VM is down, okay, still your application is accessible because your application is running in 3 containers, that too in 2 different machines. Okay, if even one container is down, Still your application is accessible because your application is running in 3 more instances. Even if this is also down, still your application is accessible because your application is running in the another instance. But meanwhile, this will be auto heal, self heal, and in few moments it will also be up and running.
Master, if master node goes down, is it working application?
No,
Since we are maintaining the replicas in working node, so
No.
is it possible?
No, if your master node goes away, what will happen? There is no one to manage that, right? Because your request will be coming through masters. Okay. So
Okay.
One more. Like,
Is it
you need to
possible?
say-
Is it possible to crash the master node in a real scenario?
yes, it will possible. That's why we will use the cloud-based services because they will give us the 99.9%
Guarantee.
uptime, like guarantee. So that's why we will use the Elastic Kubernetes service or the Azure Kubernetes service. So the uptime of the availability of the control plane or the master will be taken by the cloud itself. Okay.
One more. In this diagram, sorry, can I ask?
You can ask.
Okay.
You can ask, right?
No. Like I'm asking that person. He's completed his question. That's all.
Okay.
Like in that diagram, you mean to say like with by using Kubernetes, we can manage the different VMs also, or only containers?
We can manage different VMs also. How we can manage means we have the auto scaling in the Kubernetes. Even if one VM is down, then automatically new VM will be created in its place. But if the CPU and memory utilization is exceeding, then automatically new VMs will be created and they will be made part of the Kubernetes by the control plane.
Wow. That is what, like, that is new thing I came to know today.
Yeah, for example, we have here 3 pods. Okay, you will understand the difference between the pod and container a little bit later. As of now, that is not required. Here we have 3 pods. Now let's say we have here 6 containers. Here also we have 6 containers. If you want to, if these 6 containers and 6 containers are utilizing the entire resources of the particular VM, we don't have any way, we can't deploy the other containers. So, but there is a need for deploying the containers. So automatically Kubernetes will create one more worker node here. Okay, that is right. That is. So now let's come to the Kubernetes architecture. Kubernetes architecture. You see, Kubernetes.
So what is the difference between big data architecture versus this one? Because that is also same, right?
Which architecture?
Big data architecture.
Big data, is it for containers?
In a way that, I mean, it also works like a master and
yeah, even your Jenkins will also work like a master and node. Master means what? Where we will execute our commands.
Yeah.
Okay, so this master node concept is there for many things.
Oh, many things. Okay.
For Redis cluster also it will be there. For Kafka also it will be there, right?
Yeah.
Okay, like this. Okay, so whenever we are talking about the master and slave or the master and worker, master is the one through which we will communicate with the entire cluster. Master will assign the tasks to the workers. Okay, so this is all about Kubernetes, how it works. Now let's go into this.
I lost those 2 classes. Is the Docker completely done?
No, Docker is not at all done. One of you guys have requested me to give some demo on Kubernetes also, so that you will decide to pay the price, right?
Okay.
Docker takes about 15 to 20 classes. Okay. Not at all done. We will continue the Docker from Monday. Okay. So now
Monday.
Kubernetes. Kubernetes, as I said, is a container orchestration platform. That means we should have the container engine already running in our workers. So Kubernetes, we can run Kubernetes, we can install Kubernetes in multiple ways. in AWS, we have the Elastic Kubernetes Service Platform. Elastic Kubernetes Service. With a few clicks, we can create our own cluster, and we have to specify how many nodes we want in our cluster, right? Based on how do we decide how many nodes we have to create? Based on our workloads, based on how many microservices your particular application is having. So based on that, how much resource each container is demanding, whether it's a dev environment, whether it's a QA environment, whether it's a prod environment. If it is dev environment, 2 or 3 nodes are sufficient. If it is a prod environment, we should have multiple nodes with a different configuration, and we have to specify the configuration of these nodes. Configuration in the sense, how much resource and how much memory and CPU we should have for worker nodes. So that we have to specify. Architect will give those details. Okay, based on
How do we, so in case of some, for example, I can run multiple applications on a single cluster, correct?
Yes, single cluster only, but in that cluster, how many nodes you want? This is a cluster.
Oh.
Okay, cluster is means what? Group of machines. How many machines you want? That will be decided by the intensity of the resource utilization by the particular application that you want to deploy in the form of containers.
Okay.
Okay, so this is Kubernetes. Now let me tell you about.
I have one question. Like at the end, like over here, this Kubernetes also we need to like install on one of the VM, and from that we need to manage it, or how it works. Like separately also we can install.
When we create EKS cluster, we are indirectly creating them. We are requesting for this control plane or the master from the AWS, and we don't need to create our VM. In the background, they will be creating this Kubernetes master plane in one of the VM. For that, we will be paying for this entire, and we don't have the ability into that control plane. And regarding that, how many workers you want to have? So those workers we will allocate, and they are nothing but the EC2 instances. EC2 instances only. Once we create the worker node groups, then where these EC2 instances will be created. Is that fine?
In terms of AWS or Azure, it's okay, but it means we cannot like launch separately Kubernetes on our server.
Yes, we can.
Even if we want to manage entire thing like infrastructure also for that Kubernetes.
We can install that using KubeADM. We will also see that practically. Using KubeADM, we can do that. Okay. That facility as well. Now let's see Kubernetes architecture. To learn Kubernetes, Docker is prerequisite, and we should have some Linux knowledge. Otherwise, also no problem. Okay, no need to have the Linux knowledge also. Kubernetes contains control plane and the workers. Control plane's responsibility is to demand or to command the workers to create the containers for a particular service, for a particular application, which is required by the particular user. Okay, now let me come here. We have the master. Let's say for simplicity, 2 workers. And Kubernetes consists of multiple master, multiple nodes. This is control plane.
There is a request from my end, simple request, like if you could try to use draw.io, you can share that this content also with us, like as a note. So whatever we have discussed in these classes, just a request.
Okay. I will try to. I did not use that at any point of 1 or 2 times I have used. Definitely, I will try to make use of that tool. Okay.
Sure, sir. Okay.
Okay. Control plane will consist of different components, and workers will consist of different components. What are the components that are installed in control plane and the workers, and what are their functionalities? Let's understand that. control plane consists of Kube API server. Kube API server and etcd and what controller manager, and after that it will be having scheduler. And when we want to talk to this Kubernetes, there are two ways to talk to the Kubernetes. Why do we want to talk to Kubernetes? Because we want to deploy an application. How to request the Kubernetes to deploy our application? We should have a mechanism to interact with this Kubernetes. For that, there are two ways. One is through graphical user interface, and the one is CLI. Okay. For this, we have a tool called kubectl CLI. Okay, kubectl tool is there with which we will run execute commands. In 99.90% of the time, we will use the kubectl CLI to interact with the cluster, not GUI. Okay, then this tool we have to install. And if we want to create a container, we will request the Kubernetes. Through this CLI, we will interact with that. The request will go to Kube API server component. Okay, so this is one of the component. I will explain you this later. Now let's come to the worker nodes, and each worker node will be having the same components. What are those components? One is the actual containers will be running in the workers only. This is container runtime we should install. In our case, it is what? Which container runtime we are using? Docker. Then one more component is kubelet, container runtime, and kubeproxy. The same components will be there in the every worker node. Same components will be there in the every worker node. Kubelet, kubeproxy, container runtime. Okay, so this is, and there is a connection. Now this is the actual architecture. Now let's understand each component. We want to create in Docker. We have seen that how to create a container. To create container, we have to request, we have to specify the container name, okay, front end, okay, like that we will be specifying that, right? So in order to create containers in the Kubernetes cluster, to deploy the containers in the Kubernetes, we have to request for that. Who will specify, I want to deploy my MySQL database, or I want to deploy Nginx container, and I should have these many replicas. Okay, like that we have to specify. That specification we will done through command line called kubectl CLI. So I want to create an Nginx container. For that, I will request, and if I execute that command, the request will go to API server. Okay, so the request will go to API server. API server, after request has gone to this, and all the cluster information, how many containers are running, how many pods are running, and all the information, how many nodes are there in our cluster, all that information will be stored in a database called etcd. etcd is a database which stores the information about the cluster. Now, here once the request came to the Kube API server, what request? I want to create Nginx application in 3 containers. I want to have 3 replicas for that. The
what is Nginx application mean?
It's a front-end application, right? Like Tomcat server is there, right?
Oh, okay.
Okay. So which background you are from, Vijay?
Python and big data.
Okay, so if you develop the Flask application, Python Flask application, we should have a server to deploy that, right?
Yeah.
Okay, Nginx is. So I want to let's deploy Tomcat server or MySQL database. Let's understand that. So I want to have three replicas of That request will be coming to Kube API server. Kube API server will pass that information to etcd. Some Laxman is asking to create 3 MySQL containers. Do we have that already? Or if we have that already, what is the status? And if that is not there, let's create that. So the earlier existing data will be stored in the etcd. The Kube API server will consult etcd saying that some person is requesting 3 Nginx containers. Do we have that already? etcd will pass the information that no, we don't have that information. So that information will be passed to Kube API server. Now what Kube API server will does is, because we don't have 3 Nginx application in 3 containers, it will come to the request will be forwarded to the scheduler. What scheduler does is, now Kube API server will send that client is asking for 3 containers of Nginx application. Please create that. Okay, scheduler will be getting that command from the Kube API server. Now
you mean the request is, I mean, you mean the request to the application or request to the
to create the application.
Create the
okay, deploy the application in the container.
Oh, deployment. Okay, deployment.
Okay. So yeah. Now Kube API server will command the scheduler to create the 3 containers for the Nginx application. Now, what is the job of the scheduler? The request is the command from Kube API server is to create the 3 containers. Because we have asked for 3 containers. So now request came to scheduler. Scheduler will decide where these 3 containers should be created. Whether these 3 should be created in the worker 1 itself, or 1 has to be created here and 2 has to be created here, or 3 containers should be launched in this, or in what way they should be created. That will be decided by the scheduler. Scheduler, what it does, it will schedule the containers. It will schedule the pods in different VMs. And scheduler now will tell that, now will tell worker 1 that please create 1 container here with the specification that is given by the client. Now what will happen? The request will go to the worker 1. In worker 1, more specifically to kubelet. Okay, more specifically to kubelet. Scheduler will tell that Kube API kubelet, please, this is the assignment. It won't directly go to here. It will schedule and pass the information to the Kube API server. Okay, telling that the first container has to be created in the worker 1. Okay, this container should be created in the worker 1. So Kube API server will contact worker 1 and more specifically kubelet. Now kubelet will act as the agent of the master. That means control plane will talk to the worker 1 only through kubelet. Now kubelet got the information that it has to create a container in the worker 1. But who will create the container? Docker will create the container. Now kubelet will command the Docker to create a container with the particular image that we will specify here. Now this
where does Docker ingest setting here? Is it the
worker 1, right? Here, see.
Okay.
In the node here also this is there, here also this is there.
Oh, every mission Docker.
Yes, in every machine we should have the Docker.
Okay.
Now this container will be created here. Who will give the container? Docker will give the container. Now kubelet will wrap this container inside a box called pod. Okay, inside a box called pod. Okay, inside a box pod. Now two containers will be created in this node. Let's say that is how they have done the scheduling. Now two containers are created here. These two containers will be wrapped inside the pod. Okay. Now these
So
three
every pod will contain only one Docker image or multiple?
we can have multiple Docker containers as well. Okay, we will understand during the course. But mostly we will have only single container pods only. But there are cases where we can have multiple Docker containers running in a single pod. Okay, these three are now created. Then what is the networking between them? There should be a networking because definitely there should be load balancing across these three containers, right?
Yeah.
So that networking will be done by the kube proxy.
Oh, okay.
This is what will happen internally.
Sir, you mean to say if request is coming for 3 containers, okay, at a time, then also the okay, then also these containers like can be created by this kube like scheduler request to kubelet, that kubelets of the one worker node or another both worker nodes, because request is one to create the three containers.
Yeah, request is one and the scheduler will decide where this particular container has to be created. That decision will be taken by the scheduler. The creation of the container will be done by the workers using Docker, and kubelet is the responsibility to manage the activities of the worker one, and kubelet is the main agent of the manager or the master. Okay.
Right, but it will be created by one kubelet in one worker in one of the node, or one of the like, or both kubelet, like in both VMs it will get request will go to them.
Request will go to both. To create this container, the request will be coming to here. To create these two containers, request will be coming to this kubelet.
Okay. Okay.
Now, what is the role of this controller manager? Now we want to create 3 containers, right? It is the responsibility of the controller manager to ensure that always 3 containers are up and running. Okay, if one of the container is down, okay, one of the container is down, but we have asked for 3. Now one is down, only 2 are running. It is the responsibility of the controller manager, and more specifically replication controller manager, to ensure that always 3 pods are up and running. Okay, that is the job of the controller manager. We have the node controller manager, we have the replica controller manager. Node controller manager will ensure that always two nodes are up and running. Okay, this is how Kubernetes works. These are the components of the Kubernetes. Okay, so to create, where can we install this Kubernetes? There are different ways. One is in AWS, we have a manager service called Elastic Kubernetes service, and Kubernetes is an open source platform. You don't need to pay for it. We have to pay for the machines on which Kubernetes is running. In Azure, is called Azure Kubernetes service.
And in this case, if you are selecting AWS Elastic Kubernetes service, in that can we select like the worker should be like I want to create only T2 micro, not like only free, not other than that.
That is your choice. That is your choice.
Okay.
Okay. Google Kubernetes engine or Google Kubernetes service, I'm not sure about that. And if you want to install that Kubernetes on our own machine, we have KubeADM too. You will see this also. Okay. These are different ways. So because I don't have my cluster up now, so I can't show any of the commands now. Okay. So, and one more thing is in Kubernetes, pod is the smallest deployment unit. Okay. So in Docker, we deploy the containers. In Kubernetes, we deploy the containers inside the pods. Okay.
Okay, okay. And this kubeadm you said like it is for the like local OS?
kubeadm is a tool to install the Kubernetes cluster that we will see. Yes, local OS we can local
On
OS
on my machine,
hold
on
on.
local machine.
Yes, it can be
Okay.
done.
Okay.
And in practice, we have a single node cluster called Minikube.
Sorry.
Minikube.
Yes, yes, you are right. Minikube to practice.
Besides Minikube, will you be showing any other application or any other cluster besides Minikube? This is local, right? So,
Even I did not use the Minikube. I always use the EKS. Okay. I don't know other tool existing, but I know Minikube will be used by the people. And that is also single node cluster, but we don't have the real-time exposure if you use this Minikube, right? So always I recommend you to use either EKS or AKS so that you will get the real-time exposure.
Real-time exposure in the sense like in the company we are using one of the cloud service, Kubernetes
Yes.
service, right?
Yes.
Not these single node clusters. Okay.
Okay. That's it for today, friends. So I don't want to take much longer.
hello.
Yes, yes.
Can you show the content for Kubernetes, please? What is the content? I mean, for Kubernetes.
Index, it's like index you can show.
Yes, yes, yes. I think they have put that in the DURGASOFT.
Will you cover namespaces and deployments, services?
Definitely. These are very basic things. Current Kubernetes by Laxman.
Like Helm chart.
Helm chart we will cover, but not intensely.
Prometheus, did you you will cover or Prometheus?
Prometheus we don't cover. That is, but I will deploy and I will show you. But Prometheus
that is the monitoring for the Kubernetes, right? That is.
Yes, yes, we will cover that. We will cover that.
Okay.
Stateful, stateless, all those things will be okay. Replica service.
I think this is not the content, actual content I'm looking for. Okay, anyway, okay, you can think that this is the Kubernetes content. Whatever the real time we do, all we will see. Okay.
Whichever is required for the.
This will be sufficient for CKA certification, right?
Yes, yes. CKA certification. This is fine.
So you will show in real in Amazon Kubernetes service only. You will show everything, command those things, auto deploy.
And one more thing, whether it's an Azure or AWS,
okay,
everything exactly same except few clicks that to install Kubernetes. Okay. Once you install Kubernetes with 3 clicks, definitely this kubectl, everything is there. Everything is same.
Same. Okay.
Okay.
No.
As simple as, like, for example, if you create your Ubuntu machine in the Azure and in AWS, what is the difference? No difference, right? Just that few clicks to create the machine, that was the only difference.
Okay.
Okay.
Is there any difference within data center installation kubeadm or in EKS? Any difference? Commands where they apply?
No difference. No difference.
No, same commands only applicable.
Same commands.
Some people say like KOps, right? KOps something. So what is different from kubectl? K6 something you say.
Ops is to install Kubernetes in AWS. It is one of the tools. We can install our own Kubernetes instead of using this EKS service.
Okay.
Okay, friends, in the chat box, they have pinged about the details. So please, you've already paid and you will be getting the link on Monday. Tomorrow, we won't be having classes. For payments, these 2 days will be allocated. If you have paid for it, then our classes will be Monday. Okay, we will continue with the Docker.
Sure,
You
sir.
have to
Sure.
pay at the end 4,000.
Yeah, 4,000.
We have to pay at one payment, or you can say we can pay 2 times like
One
installment.
payment, yeah, one payment you have to make
One
it.
payment.
That we will check with the
Yeah,
management.
just confirmation.
Yes, yes, that is fine.
No.
Hello, Laxman sir. This side Amar. Are you audible? Am I audible, sir?
Yes, you are audible very clearly. Amar, where are you from?
Sir, actually, I am from Bihar, Chhapra district. Okay. Right now, I am in native place, so I have joined from here. Sir, actually, I have some basic question. That is, I have basic knowledge of Linux. Okay, and simply you can say that command. Okay. So I saw that some online classes going on for Kubernetes and Docker, and so I have joined. Okay. So as I see, most of the guys who have already knowledge of Kubernetes. Okay. And here as I see from last 2-3 days, my understanding is very less. Okay. So it is right batch to should I join, or some prerequisite I should learn before joining this batch?
No, there is no prerequisite, and you said you have Linux knowledge. That is well and good, and that will help here. Not much will help you, but that is good. And we just have beginner classes. This is something like demo classes, and those 3 or 4 classes you can watch. If you contact the management, they will provide you the links, and you can watch that. And in these 2 days and 1 day onwards, we can continue with that. Is that fine?
Yes. Okay.
This is the right batch. This is a fresh batch only. All these people are freshers. Fresh. I mean, fresher. I mean, they are newly joined. We did not progress much on this.
Okay, sir. Okay.
Yes, and Amar, these all are only commands only. We are using commands only over here also. Nothing difference.
Yes,
if you have basic.
but yesterday I was watching the session. So sir was putting copy from the document and pasting on the server, and he was installing a lot of things. Okay. So I was not able to understand the meaning of that command. What is doing? Okay.
They are explaining, na. They are explaining before copying, like each and every. If you watch previous all videos, you will get to know. Like I also in that dilemma, but I have watched that all 3 videos. Then I came to know like what is the process.
You have to watch multiple times. If you not understand, then you can pause and you can write, and you can even he told -d means what, -p what. So he explained. Yeah, you can watch multiple times. You will get to understand. I think, as of my opinion.
Okay. So Saturday, Sunday, I will go through the all recording session and try to understand. Okay.
Yes.
And again, I will join on Monday.
Okay. If you understand that, then only you will join. Otherwise, you will take some time and you will join the next batch.
Sure, sir. I will put my effort on Saturday, Sunday. Try to understand.
Okay. Fine then.
Yes, you will definitely understand, Amar. No problem at all. One question, sir. Should I ask? Anyone want to ask any question? Like yesterday we have discussed regarding volumes. Hello.
Yes.
Yeah. Like Docker volumes. Are we like today we requested for Kubernetes? It's fine, but we will discuss that Docker volumes in details now, like how we are sharing.
Yes.
Okay, and one question in terms of that only, like at the end, if Kubernetes, like if the Docker is using the resources from the VM only. Oh, okay. So if we have created the volumes in one Docker, okay, and we are one container and we are sharing this with another container. So we take an example, and they both can see the what's in that volume, okay, or what's in that directory at the end. So my question is like, if we do have the access with that VM, okay, on which that both the containers are created, from that VM also we can access that volume or not?
Yes,
or that
we can access. We have seen that, right? We can go to that directory varlib docker and volumes, and then you can go to a particular volume, and that is there in our. It is something like your files only.
Yes.
Right. Okay, Vijay is asking for previous class. I think you will be getting that through mail. If you did not get that, please make a call to them. They will definitely mail you the link, Vijay.
Yeah, 2 to 3 times I also called them. Then they have sent. They are a little bit busy, I guess.
Okay, they may be busy in some other work.
And one more, sir, can just from my end, will you be sharing your contact details also to me at least? Actually, I need if
I
I
will share these notes, entire document with you. Entire thing I will be sharing with you.
contact. I am asking contact details.
Contact details according to this institute policy, I can't have that, but I hope that you will be created and joined in a Telegram group. There we can discuss and you can text me also there.
Okay, no problem.
Is that clear? So I think I got a mail from this people. I think you must also be getting this in the mail. If you can please check that this demo videos link is there.
Yes.
Okay. Okay, friends, let's leave.
Okay, we'll meet on Monday, sir. No problem.
Okay, Vijay, you please check with them. I think they have already sent a mail to you. Otherwise, ping them once. They will definitely provide you the link. And these are numbers that they are giving in the mail. I will send them to you in the chat box. Where is my chat box? Okay. Ping them. Okay, friends. Thank you for attending. Let's meet on Monday. Thank you.
Thank you, sir.